So this is the second part of lesson 1.3. We talked about multiplication and how multiplication is just a quick way to count things, and that's a useful tool. Then we looked at this tool called distribution, this property. And basically the idea of distribution is you take a multiplication problem, you break it into two smaller problems that are easier, and then add or subtract to finish it up. Now keep in mind that the standard algorithm always works. Multiply and add, and you got to carry that number over there. But for small numbers, if you can use another tool, that's usually better. So on the third page of our notes here, let's look at division for a couple minutes. All right, division is the opposite or the inverse of multiplication. Okay, so keep that in mind. It's just the opposite. So if we know that 3 times 7 equals 21, then I should put if. Then if I take 21 and I divide it by 7, that means kind of breaking it into groups of 7. I'll go ahead and write it out. We're going to write division as a fraction, but we know 21 divided by 7 is 3. You can think of it as asking, what number do you multiply by 7 to get 21? And that number is 3, as we just saw. Okay, so that's the idea. So division flips this around. Division says, all right, well, in this example we did in the first part, we had some grass that we needed to find the area of. Well, division says this. How much, or I'm sorry, you have enough grass seed in a bag to cover 350 square yards in your front yard. So you could go 35 by what? Well, we're just asking, well, what can we multiply 35 by to get 350? And, well, so we just think about, 35 times what, question mark, equals 350? Well, that question mark is going to be 10, right? So this guy is 10. Because easy to see that 35 times 10 is 350. Okay? Or we can use division, right? Division just says take 350 and divide it by 35. What number times 35 makes 350? It's 10. Okay, so, oh, there it is. Since 7 times 3 is 21, 21 divided by 7 is 3, we said. Okay, or 21 divided by 3 is 7. Okay, so something to note, we can write division in a few different ways. We can write it using this little symbol that you've seen for many, many years since you were in elementary school. But more often we'll write it as a fraction, 21 over 7. 21 over 7 means 21 divided by 7. Okay? Or we can write it as 21/7. Okay? Or we can write it, if we write it in, using the division stacking form there, we can do 21 divided by 7. It'll look like that. That means the same thing, kind of the longhand version. Okay, standard algorithm. So we always want to keep in mind what it means, what a problem means. So 21 divided by 3, we want to write these in their alternate forms and then simplify. So 24 divided by 3. Well, that's the same as 24 over 3, right? Or, we can write it as 24, you can write the longhand form divided over 3. Okay, 24 divided by 3. Those all mean the same thing, all right? They're all equal. I'll get that out there. It's kind of confusing, okay? And so that's what we're talking about. 24 broken into groups of 3. How many groups of 3 could we get? Or you can say 24 broken into 3 groups. So if you want to make 3 even groups, how many would you have? Well, it'd be 8. because 3 times 8 is 24. So 24 divided by 3 is 8. Okay. 49 divided by 7. Well, that's just 49 over 7. Or 49 divided by 7, if you want to think of it that way. And what number do you multiply 7 by 7 to get 49? It is 7. Okay. Now, how about 143 divided by 13? Oh boy, that's getting a little more challenging there, huh? Okay. Well, let me show you how our distribution can work here. Imagine that we had 143 things that we wanted to break into groups of 13. So we start making, lines of 13. This is not 13. I'm just scribbling here. Okay, we kind of keep stacking groups of 13. Okay, and we continue on. Well, at some point, I'd hit a number. I know that if I went out 10 groups of 13, that would be 130, right? That's an easy multiply. 13 times 10. Okay, easy to multiply by 10. And I'd have some leftovers if I kept stacking up donuts in groups of 13s. Okay, I'm doing groups of 13. Okay, and if I've already grouped up 130 and I need 143, what's 143 minus 130? I think that's 13, right? Oh, I guess I just need 13 in this leftover, because 130 plus 13 is 143. So let's think about how we can break this up. So maybe a better way to do this, instead of just doing the whole 143 broken up to 13, we can break up 143 into 2 easy numbers. And I'm going to break it up into 130 plus 13. Okay. Why did I break it up? Because I can divide 130 by 13. That's easy. I can divide 13 by 13 easy. So this is 130. I'm going to do it in 2 parts. 130 divided by 13 and 13 divided by 13. What's 130 divided by 13? It's 10. 13 divided by 13, it's 1. So our answer is 11. Okay, that is one way to do it there. Okay, we'll talk about longhand division in a second. But that's a nice way to do it. Break it into 2 easy problems, solve both of them, and then put it back together. Can you try that here? 65 divided by 5. What is a multiple of 5 that you know that is close to 65? How about 5 times 10? 5 times 10 is 50. And then we need to think about how much more we need to get to 65. From 50 to 65, that's 15. That's right. So we're breaking up 65 into 50 and 15. So we're going to do 50 divided by 5. And then 15 divided by 5. There's other ways you could break it up. You could break it up in any way, any 2 numbers that add to 65. You could do this. You pick 2 numbers that 2 numbers that are easy to divide by 5. And so this is 10. 15 divided by 5 is 3. So this is 13. Okay? And a lot of this can happen in your head. That's the idea. Don't stress about how to write it out. So there's a nice tool. Make 2 easy problems, divide them both, and add them back together. Now, on the last page here, we're going to look at some long division. All right, sometimes we've got to kind of divide it by hand. So we'll do the standard algorithm here, okay? And we're going to have some leftovers. Okay, so here's our standard algorithm. Now, a lot of times we use in practice, we'll use calculators for these kind of things, but when it gets too crazy. But we got 2,398 divided by 5. So we're going to write this in our little division box here. So this means 2,398 divided by 5. This is how we write it in this box. We put the number being divided in here, and this number called the divisor out there. Now we're going to ask ourselves, does 5 go into 2? No, you cannot divide 2 by 5. Okay, so we're going to go to the next. We're going to take two numbers. How many 5s fit in 23? Well, the most 5s that we can get is we can get 4 of them, because 4 5s is 20. So now we're going to multiply. So we get 20, multiply 4 times 5, and then we're going to subtract. 23 minus 20 is 3. And then we're going to bring the next number down. Bring that number down. Now we have 39. How many times does 5 fit into 39? Well, 5 does not multiply perfectly into 39. Okay, but we can get there 7 times. 7 times 5 is 35. So we're going to multiply 7 times 5, and we write the result down under here. So 35 is as close as we can get to 39 using 5s. Now we're going to subtract. 39 minus 35 is 4. We'll bring down the 8. And we ask ourselves, how many times does 5 go into 48? And it does 9 times. So that is 45. And we subtract, and we get 3. So we have a remainder of 3. Okay, so sometimes, you can write this remainder of 3. Okay, but really what that means is this: we have 3 of these 5s left over, 3 of these 5s. So the way to write that is our answer. This is 479, and we have 3/5 left over, because 5 is what we're going to divide. We're dividing by. And using a calculator, you can get a decimal there, but that's the exact answer. So when we have a leftover, this is the remainder here. That remainder becomes a fraction using the divisor. Well, what if it's like this as a fraction? Well, remember, this means 1,563 divided by 7. So that top number is going to go in the division box, and we're dividing by the bottom number. We read it top down. Top divided by bottom. Now, by the way, if you're confused by the fact that a fraction means division, look at this. Look at this symbol right here. See this symbol that you used since elementary school? What does that symbol look like? It looks a lot to me like a fraction. Looks like we have something divided by something, something over something. We have 2,398 divided by 5. That number is just, all right? So really, ever since you've been using this division symbol, you've been writing that division is a fraction. That little symbol is a fraction, kind of a generic fraction. All right? So that's what's going on. All right? So I'll work these out, but you may want to pause the video, and you can try these 3, and then watch the video or skim through the video there and check it out. All right, let's work through this here. So ask ourselves, how many times does 7 go into 1? It doesn't. So we're going to take 2 numbers there. How many times does 7 go into 15? It goes in there twice. I can get 2 7s fit into 15. 2 times 7 is 14. We're going to subtract, and that gets 1. Bring down the 6. Again, how many times does 7 fit into 16 now? 7 fits in there twice. 2 times 7 is 14. And we subtract. Bring down the next number. How many times does 7 fit into 23? Well, now we can get 3 of them, right? 3 times 7 is 21. So what this does is it allows us to take a big number and kind of chip away at it. Okay, so this is our remainder. And so our leftovers is 2 of the sevenths. Okay, so we couldn't divide that by 7. We divided all of this by 7, and we divided as much out as we can, but we have a little bit left over, and that's a fraction of a whole. Okay, so 2/7. So 223. Oops, too many 2's. 2/7. All right. Okay. How about this guy? We've got 4. 2, 2, 1. Again, if you haven't done so and you want to pause it and try it, go for it. How many times does 21 go into 42? Well, it goes in there twice. 2 times 21 is 42. And that gives us, when we subtract, 0. That's interesting. Bring down the 2. How many times does 21 go into 2? Or 02, which is just 2. It doesn't at all. So we got to put something down. So we put a 0 down above that second digit. Okay. And then 21 times 0 is 0. We subtract and we get 2. Bring down and we get 1. How many times does 21 go to 21? It goes in there once. Exactly. 1 times 21 is 21. And we subtract and we get 0. So our remainder is 0. That means there's no fraction. So this is exactly 201. So we don't always have to have a remainder. Sometimes it fits perfectly. 21 times 201 is 4221. Okay. Kind of an interesting result there. Last one. All right. How many times does 33 go into 69? I think, well, 3 times is too much. 3 times 30 is 90. So 2 times. 2 times 33 is 66. Okay, and we subtract and we get a 3. We get a different color here. So we're going to subtract there and we get 3. Bring down the 0. Does 33 go into 0? No, it does not. 0 times 33 is 0. So we kind of do this step when it doesn't fit. We still do the 0. We still subtract. And then we're going to get a 3-digit number. Okay. And does 33 go into 305? Well, 10 times 33 is 330. So 10 is too much. Let's try 9. So we try 9. And by the way, 330 times 9, when you think of that as 330 times 10 minus 1. 330 times 10 is 330. 330 times 1 is 33. So 330 minus 33, let's take 30 away from 330 and you have 300. Take 3 away from 300 and you have 297. Okay. So 9 times 330 is 297. So we're using all of our tools here. Subtract, we'll just count up. How far is it from 297 up to 5? Well, it's 3 and 5. That makes 8. Okay. And we're almost there. We bring down the 5. I still think we can only get 2 out of there. That's 66. Because 3 times 33 would be too big. And we subtract. Okay. Well, what's an easier one? What's What's 86 minus 66? That's 20. If we're doing 85, that's a little closer. These two numbers are closer, so this is 19. See that? And that's your remainder. So we have 19/33. Write it again over here. All right, so there's longhand division. All right. Now in applications, we'll use our calculator a lot for that kind of numbers. All right, so last little bit here, and we'll wrap this up. A couple applications. So we got a conventional refrigerator that will run 12 hours each day. Okay, and we can use 150 watts of power each hour. How many watts of power will it use over the day? Okay, so we gotta think about this. We have 12 hours and 150 watts. That's the measurement of power. Are used each hour. We want how many watts it will use over the whole day. So we got to ask ourselves: are we going to divide those or multiply them? Well, if each hour is 150 and we're doing a whole day, a 12-hour day, all right, well, it's going to be more than 150, right? So if you want to make this bigger, this is going to be a multiplication thing. 12 times 150, all right? And we might break that up into 10 times 150 and plus 2 times 150. I'm using the distribution there. I broke 12 up into 10 and 2. That's one way to go. When you multiply by 10, you just put a 0 on the end of it. And this is 300. So that's 1,800. That's one way to do it, one way to multiply. So, and then our units, got to have your units. We're talking watts. You might ask, what is a watt? There's a corny joke for you. All right. It's supposed to be an A there. Actually, the abbreviation is just W. We'll go that route. All right, so one more. We got a concrete sidewalk that is laid in square blocks, and they're measured 5 feet on each side. We want to make a 180-foot long walkway. The question is, how many blocks will there be? So we got 180 feet total, but we're going to break it into fives. Is this a division situation or a multiplication? I think it's a division, right? We got 180. We need to divide it by 5. Okay. So we can do this a couple ways. Let's break 180 into 180 and divide those by 5. Again, using that distribution idea. 2 smaller problems. How many times does 5 go into 100? That's 20. How many times does 5 go into 80? Well, 5 goes into 48 times. So you might say, I don't know. I'm not familiar with that. I don't know. That's getting kind of big. So let's break 80 up. Let's break 80 up into 40 and 40. Maybe you can do that. So find multiples that you're used to, and notice these all add up to 180. 40 divided by 5 is 8. 40 divided by 5 is 8. Break it up differently if you need to. Whatever's familiar to you. Now 20 plus 8 plus 8, that's 20 plus 16, that's 36. So that's 36 blocks. We're going to break this into these 36 different little blocks. Okay? All right, well, that's the idea. Hopefully that gives you a good jump start into division, and we'll be using that often. So keep it up. And now you're ready for that 1.3 assignment if you want to practice that.